Welcome. In this session, we will do an example where we find a slant asymptote. Again, to keep things simple, we will take a function with small degrees. The function is x squared minus 2x plus 2 over x minus 1. In the next session, we will actually graph this. So we'll find both the vertical and the slant asymptotes. The numerator doesn't factor, so this fraction cannot be reduced any further. The only vertical asymptote is x equals 1, where the denominator is 0. Because the numerator has larger degree than the denominator, there is no horizontal asymptote, but there is a slant asymptote. Our method for finding that is to do long division. We just need the quotient, but we'll go ahead and do the complete long division. Let me first remind you how to do long division. When you are finding slant asymptotes, the long division will be very short because there should only be two terms in the quotient. I start by dividing the first term in the dividend, the numerator, by the first term in the divisor, that is the denominator. In this example, the first term in the numerator is x squared. I should say a highest degree term rather than first term, but we'll assume that you have written it in standard form. In the numerator, the highest degree term is x squared. In the denominator, the highest degree term is x. X squared over x is x. So that's the first term in the quotient. Now I multiply the entire divisor, or the denominator, by the term I just found. So I multiply x minus 1 by x. That's x squared minus x. I take its opposite because I'm going to subtract, so I take the opposite and add. Equivalently, I just multiply by the negative of the term I found, negative x times x minus 1. So that's negative x squared plus x, and now I add. If I did this right, the highest degree terms will cancel. So in what is left, the degree should be 1 less than before. Minus 2x plus x is negative x, and then I have plus 2. I repeat this process. Highest degree term in what is left of the numerator is negative x. I divide that by the highest degree term in the divisor, namely x, that gives me negative 1. So the next term in the quotient is negative 1. I'm going to subtract negative 1 times the denominator x minus 1. That's equivalent to adding negative of negative 1 times x minus 1. So I add x minus 1. Negative x plus x is 0, and 2 minus 1 is 1. So the quotient is x minus 1. Now, I never explained why, when you do long division, if you get a linear quotient, that gives you the slant asymptote. Let me explain that using this example. The consequence of long division is that the original fraction can be written as a polynomial, namely the quotient, in this case x minus 1, plus the remainder divided by the denominator of the original fraction. So in this case, 1 over x minus 1. Long division works by producing a remainder. The remainder always has smaller degree than the divisor. So in the fraction part of the answer, I get a proper fraction, so to speak, one in which the numerator has smaller degree than the denominator. So that will have limit 0, both at infinity and negative infinity. So f of x minus the quotient has limit 0, both at infinity and negative infinity. In other words, the graphs of the given function and the graphs of the quotient approach each other on both ends. Because the quotient is linear, the graph is a straight line. The graph of the function f of x approaches the graph of the straight line y equals x minus 1 as x goes to infinity or negative infinity. And that's precisely the definition of the slant asymptote. This explains why you can find slant asymptotes of rational functions by doing long division and taking the quotient. Anyway, let me record the asymptotes of this function for use next time. The vertical asymptote is x equals 1, the slant asymptote is y equals x minus 1, and note that the function equals the quantity x minus 1 plus 1 over x minus 1.